Okay, so plan for today. We are looking at numeric data again. So far what we've done is we looked at all things categorical data. And when we looked at the categorical data, we had normally a two-way table. Sometimes you pulled a percentage out of it or a proportion. Sometimes you made a graph. Categorical data is easier to analyze than numeric. Numeric's got a little more to it. And so what we did then is we looked at numeric data with graphs. So when you have your numeric data, generally as a statistician, the first thing you do is you make a graph. And then what we're going to do today is come up with some numeric summaries. So when you did CSSU, we had to guess at the center, we had to guess at the spread, just estimate it. Today we're actually going to calculate it. And then of course, this will be on the calculator and by hand. Okay, so this is the page that I need us at. Probably you're already here, but if you're not, find it please. Okay, so first thing that we're going to talk about is some symbols. Both of these symbols here, the first one we pronounce X bar, and the second one is mu. Both of these represent mean. And maybe you've heard that term, maybe you haven't. That's just the stats term for average. So when you see X bar or mu, both of those represent the mean or the average. But there is a very big difference. X bar is the average of a sample. Mu is the average of a population. So we use X bar to estimate mu. So often we want to know something about a population. Like I might be interested in the population of Prospect High School students. And I might want to know what is the average amount of time that students spend on homework. I would find mu then if I asked every single Prospect High School student, how much time do you spend on homework each night? Now, we know that's not practical. So instead, what I'll often do is I'll take a sample. Maybe I would take you all as my sample. It's not a great one, but it's convenient. And I would ask you, how much time do you spend on homework every night? If I average that out, then that would be X bar. Because it's just a sample, it's not everyone in the population. Okay, so the formula to find the mean, or to find X bar, you guys have done this before. You're taking every observation and adding them all up, and you're dividing by how many there are. That is the long way of writing it out. You can also say, I'm going to sum up X and divide by N. So that's what the big sigma means. Big sigma means sum. Okay, mean is just one measure of center. So when we say measure of center, there's actually three of them. Mean, median, and technically mode is also a measure of center. I'm putting mode in parentheses because statisticians do not use mode. It's not used. So why we learn it, I don't know. But mean and median are the two that we're going to focus on. Okay, first data set, well this is the data set we're going to keep with for most of class, is these numbers represent commute time for a sample of 20 people in New York. So how long it takes them to commute to work, let's say. One person took 10 minutes, 3 minutes, 5 minutes, our highest one takes 85 minutes. If I asked you to find the average, could you? Are you going to add them all up, divide by 20? If I asked you to find the median, could you do that? How would you start? Median?
Organize it from smallest to largest.
Okay, do you guys remember organizing smallest to largest, crossing out on each end? Okay, we're not going to do that by hand. That's a complete waste of our time. So instead, I'm going to show you how to do it on the calculator. You always have to show work, though. So if I want us to find the average, first thing you're going to do is you're going to show a formula. And so you're going to say, I'm taking the first number, adding the second number, all the way up to, in this case, I told you there are 20 of them. And we're dividing by 20. Then you have to show a substitution. I at least want the first number and the last number. At a minimum, that's what I want. So I'm taking 10 and I'm adding all the numbers in between until I get to 45, and then I'm dividing by 20. And then we're going to go to the calculator. Okay, so we got a mean of 31.25 minutes. The average is not rounded. Please do not round that. And then the median, we got to be 22.5 minutes. Do not round either of those. In stats, the vast majority of the time, you're not going to be rounding. Okay, keep those numbers in your calculator because we're going to use them again in a little bit. Okay, so those are our first two measures. Now, one thing that we want to talk about is often in statistics, we refer to what is called a resistant measure. A resistant measure is not affected by extreme values. So if we look at these New York commuter times, we have this person right here that took 85 minutes to get to work. That person is unusual based on the fact that our average is only about half an hour. Okay, do you think that the mean or the average was affected by that person that took 85 minutes? Yeah, for sure it was. Was the median affected by that 85? No, right? The median's in the middle. So those extreme values are not going to affect the median. So is the mean a resistant measure? No, it is not. The mean is definitely affected by unusual values. Okay. So let's keep going. What you will often have to be able to do is estimate the mean or the median from a histogram or a dot plot. So I want us to draw a very simple example that goes from 1 to 8. There's 1 dot at 1, 1 dot at 2, 1 dot at 3, 1 dot at 6, 1 dot at 8. Okay, the median we should be able to tell right away. Median number in the middle, 3, right? 1 in the middle is 3. Okay, what is important for me, I don't care if you can come up with the actual value of the mean. What I care about is it going to be smaller or bigger than the median? That's what I want you to know. These values, the 6 and 8, are a little bit unusual. They're a little bit extreme. They're going to affect the mean. So what that tells us is if here's our median, it's going to be pulled towards the unusual values. So all I need you to be able to say is that the mean in this case is going to be bigger than 3. If you were to guess, it's around 4. I mean, not around 4, it is 4. Here's the actual meaning of that. If you picture all of those dots as being 1 pound weights, so picture you have like a flat piece of wood and you have 1 pound weights at 1, 2, 3, 6, and 8. That board would be balanced at 4. That's the mean, it's the balancing point. Okay, this one we already answered, I think. Is median resistant? So is median resistant to extreme values? Yes. Okay, shape is related to mean and median. What I need you to know is similar to what we said before. If you have a symmetric distribution, the mean or the average will be about equal to the median. If your distribution is skewed, So there are some unusual outliers. The skew pulls the mean. So for example, if we have something like this, this is our distribution. First of all, is that skewed left or right? Left. So this one is skewed left. So what that means is the mean is pulled down towards the tail. So in this case, our mean will be less than our median. Okay, we got the rest of this page to finish, then we'll take our break before we keep going. Okay, that is center. That's what you need to know about center. Center is mean, median. Spread has got two measures, one of which you have heard before and one of which is probably new to you. The first measure of spread is range. So range is the biggest number, subtract the smallest number. So then what we want to know is range resistant. So is it resistant to outliers? No. Because all it looks at is the biggest and the smallest. Okay, next thing we got to talk about is quartiles. Now, unfortunately, we do need to order these numbers to find the quartiles. So we're going to do it by hand, and then I'll show you how to do it on the calculator. Please make sure I'm doing this correctly and that I don't miss a number. So the smallest one is 5. And then I think we have 10, 10, 2 10s. Okay. So then we have 15, 15, 15, 15. So 4 15s. And then 20, 20, 20. Am I good so far? Yeah, thank you guys for following me. Okay, 25. And then we have 30, 30. And then we have 40 and 40. And 45. And then 60, 60, 65, 85. Ooh. Okay, there's 2 quartiles that you're going to find. Before you find any quartiles, the first thing you have to do is cut your data set in half. So this is a data set of size 20. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this right here is where we can cut our data set into 2 halves. Your quartiles then are just the median of the first half and the median of the second half. So if we go and find the median of the first half, if I cross out 2 from one end, 2 from the other, 2 from one end, 2 from the other. So we take the average of the 2 in the middle, which is 15. So this is called the lower quartile, which is denoted by Q1, and that number is 15. Similar idea on the upper end. If I cross out maybe 3 from each end just to be efficient, and then 1, I'm now taking the average again of those 2 in the middle. So this is called the upper quartile, which is denoted by Q3. It's the average of those 2 numbers, so it's 42.5. Okay with that? So those are your quartiles. This can be done on the calculator. That 1 var stats that we did, if you scroll down, it gives you Q1 and Q3. Okay, I need like 4 more minutes and then we'll take a break. This is a little bit different or looks a little bit different if you have an odd number of observations. Well, so let's say our sample size or our sample is just the numbers 1 through 7. Okay, we can't cut this evenly into 2 and 2. And so what you do is you cut right here down the middle, but you don't use 4. So 4 isn't included. So in this case, we can pretty easily see our first quartile is 2 and our upper quartile is 6. Now, that being said, you're always going to have a calculator, but sometimes it's easier, like in this one, to just find your quartiles by hand instead of putting the numbers through a hat. Okay, so the logical question is, why do I care what the quartiles are? And it's because they are related to interquartile range, IQR. The way to find IQR, or the interquartile range, is you subtract those two numbers. So if we take 42.5 and we subtract 15, I think we get 27.5. Okay, so my question for you is IQR resistant? So is IQR going to be affected by outliers? No, probably not. So is IQR resistant? Yes, it is. And again, the question is, why do we care about IQR, besides the fact that it is a resistant measure of spread? And that's because it helps us find outliers. So when we were doing CSSU, we were just taking an estimate as to whether or not observations were outliers. So an outlier is an unusual observation. There are outliers on the high end and the low end. Outliers on the high end will be greater than Q3 plus 1.5 times the IQR. Okay, so in this case, our Q3 is 42.5, and our IQR was 27.5. So any number greater than 83.75 is going to be an outlier. So that person who took 85 minutes to get to work is an outlier. The low end will be any numbers less than Q1 subtract 1.5 times the IQR. So our Q1 was 15, subtract 1.5 times that IQR. So anything less than negative 26.25 is an outlier. Obviously, that doesn't make sense in our case. Just tells us no outliers on the low end. Okay, last thing before our break is what is called the 5-number summary. 5-number summary is 5 important numbers: the minimum, Q1, the median, Q3, and the maximum. Your calculator gives this to you. So if you do that 1var stats and you scroll down, it gives you these 5 numbers in order. The minimum in our case is 5. The Q1, which we found, was 15. We found the median to be 22.5, I think. And then 42.5, and our maximum is 85. So that is called the 5-number summary. It is displayed, which we're going to talk about after the break, in one more graph. So I guess I kind of lied to you. One more graph, which is called a box plot. Okay. Questions before our break? Okay, so we've talked about measures of center. We've looked at the first few measures of spread, and we've talked about the 5-number summary. So what we're going to do now is use that 5-number summary to construct a box plot. Okay, so again, here's the same data that we have been using. The box plot is going to use our 5-number summary. So first thing that you're going to do is you're going to give yourself a scale that goes from the first number to the last number, and then you're going to scale it. So I'm going to maybe try to go by tens. So this would be 15, 25, 35, 45, 55, 65, 75, 85. Whoops, didn't give myself enough room. We're going to put a label. So this is in number of minutes. We're going to put a title, like New York commuter data. Okay, box plots you probably saw before, like maybe in elementary school, maybe middle school. Sometimes they're called box and whisker plots. They are going to start with the 5-number summary. The box is made from Q1, the median, and Q3. So Q1 we said was at 15. The median we said was at 22.5. And Q3 we said was 42.5. So this is my box. So for your sake, it might be best if you write, this is Q1, this is the median, this is Q3. I don't want those on every box plot, but it might be helpful. Okay, next thing you need to know, you always put a dot at any outliers you have. So we already said this person that took 85 minutes is an outlier. That was the only outlier we had. Your whiskers then extend to the last observation that's not an outlier. So on the high end, 85 is an outlier. So the next highest that wasn't an outlier is that 65. So that means that this upper whisker is going to go to 65. On the lower end, there is no outlier, so all we're doing is going down to that lowest observation, which is 5. That is a box plot. Okay, so when you're doing a box plot, since we already did all of the steps, you're going to find the 5-number summary. And then you're going to check for outliers. Fun fact, there's actually a way to do this on your calculator, so I'm going to show you that also. So find the 5-number summary just right off the calculator, check for outliers showing work, and then draw your box plot. Okay, 2 common errors. The first one is when people use IQR as a range of numbers. So people will say something like the IQR is from 15 to 42.5. That's not true. IQR is a single number. It's not a range of numbers. So the correction would be the IQR is 27.5. It's one number. That's it. And the second one has to do with shape. So what can you learn about shape from a box plot? Nothing. You cannot tell shape from a box plot. And that's because a box plot is only based on 5 numbers. That's it. So I can change any of the numbers in here, any of the numbers in here, any of the numbers here, and end up with the same box plot. So if I were to ask you to describe the distribution, we're not going to, but if I were to ask you to, you would say to yourself, okay, this is numeric, so I'm going to do CSSU, except no shape. And we already know a bunch of the measures. The center is 22.5. We calculated it. the spread, we would say is from 5 to 85. But the IQR is 27.5. And then there's one unusual. Next thing to talk about, parallel box plots. We use these when we are comparing. So in general, you would have something like box plot number 1, and then underneath it, you would have box plot number 2. There's one on top of another. So like if we looked at Chicago commuter time also, maybe we would have New York and then we would have Chicago beneath it. Okay, how do we compare them? Well, it's numeric data. So again, CSSU, except no shape because you can't tell shape from a box plot. Okay. Last thing we have to talk about is standard deviation. Questions about 5-number summary, box plots, the calculator, anything like that? Okay. So what we need to know about standard deviation is it's a measure of spread, and it is the typical deviation from the mean. Okay, so there are 2 symbols for standard deviation, S and sigma. Sigma is when the standard deviation comes from the population. S is when the standard deviation comes from a sample. So that is similar to X bar and mu. Most of the time, we're going to have S, not sigma. So calculating standard deviation for the population, rather. So we're calculating sigma. Okay, if you go through word by word what standard deviation measures, the formula should end up making sense. Deviation is the difference between an observation and the mean. So we take each observation and we subtract the mean. So that's how you're going to start. Now, because some of those numbers are positive and some are negative, you end up squaring that quantity for every observation. Then you're going to have to add them up. Typical means average, so we're going to have to divide by how many there are. And lastly, because we squared, you're going to end up taking the square root again. Variance is the square of standard deviation. So if we take that sigma and we square it, or written like that, that is called variance. And that variance is difficult to interpret. Because it has units that are squared. And you'll see that in a minute. Okay. When we start taking standard deviation for a sample instead, there's one big thing that changes. So because it's a sample and it's not the population, first of all, we don't have mu. We don't have the population mean. We have a sample mean instead. And then we divide by n minus 1 instead of n. I haven't told you this, but you do get a formula sheet for the AP Stats exam. I'm not giving it to you yet, but you will get it eventually. And this formula is on the formula sheet. Okay. Questions for me before we look at how to use this formula? Okay. So here we go. We have a random sample of 5 students, and they were asked how many minutes they spent doing homework the previous night. There are the responses in minutes. We are calculating and interpreting the standard deviation. So first thing, write the formula. We're going to take every observation, subtract the mean, square it, and we're going to divide by n minus 1. First thing we're going to have to do is calculate the mean. I assume that you can do that, so I'm just going to do it quickly for you and tell you what I get. The mean is 41. Okay, so then what we're going to have to do is we are going to have to take each x and subtract the mean. Okay, so we have x values of 0, 25, 30, 60, and 90. So all of those we're going to subtract 41. So we're going to end up with negative 41, negative 16, negative 11, 21, and 51. No, not 51. 49. Should it be 19 instead of 21? Does that look better? Thank you. Okay, so far what we've done is we've done the x subtract x bar part. Those are the numbers we got. Next thing we're going to have to do is square them and add them up. So now what we're doing for each of these numbers, we're going to square them and we're going to add them up. And if you trust me, you get 4,820. Okay, so then we're going to take that 4,820 and we're going to divide by n minus 1. And then we're going to take the square root. And that gives us a standard deviation of about 34.7. We did that so that you can see how the formula works. Practically, you're not going to use the formula, you're going to use the calculator. Okay, I need 5 minutes. And then I'll give you the last 5 minutes to pack up, grab your phones, talk to each other, whatever you want to do, because I know this has been a long class. Okay, to find this on the calculator, you would do that 1 var stats again. So on calculator, it's listed as S sub x. There's also a sigma of x, and that is not the one that you're using. Always S. To interpret this, this is the typical deviation from the mean. So we would say typically the number of minutes students spent doing homework deviates by 34.7 minutes from the mean. Okay. Few things for you to know. Standard deviation is 0 or bigger. It is not a resistant measure. You are never going to say that standard deviation is large or small. It's only used for comparison purposes. But a larger standard deviation does indicate more variability. These are the last two things I want to talk about. So we're going to skip the one question. I do want to talk about these two. If you have a data set and you need to choose a measure of center and a measure of spread, if your data set is symmetric, you're going to go ahead and choose the mean because it's the average and people like the average. And you're probably going to choose the standard deviation because people like that also. It's related to the mean. But if your distribution is skewed, that affects the mean and the standard deviation. So those are no longer our best options. If your distribution is skewed instead of the mean, you're probably going to choose the median. And instead of standard deviation, you're going to choose the IQR. Okay, last thing. It is very common that you are asked to read computer output. So we are going to look at a lot of computer output. Here's one example. There's a dot plot and then there's some numbers below. Here's what you need to be able to identify. So I would highlight these. You need to be able to find n, which is the number of observations. You need to be able to look at the mean and the standard deviation. And then lastly, what you're going to notice is you have the 5-number summary. So what you could do with this output is the question could say, construct a box plot. It gives you the 5-number summary. You would check for outliers, and you can make a box plot just off of the yellow part that you have right there.